Today we're going to talk about compounding interest. So we'll start with our definition. Another method of paying interest is the compounding interest method, where interest for each period is added to the principal before interest is calculated again for the next period. So in other words, on the next period, you're earning interest on more than just the principal amount. So if you put in a principal amount and then you let it sit and you earn an interest payment, and then the next period around you're earning interest on the principal plus that first interest payment. So every time you get an interest payment, you're earning a little bit more interest on the next period. So we'll start with our first type, future value with an annual compounding. So the formula for that is that our future value S will equal P times 1 plus R all to the N, where S is the future value, that's how much you have in the account at the end. P is the principal amount, that's how much you start with at the beginning, how much you invested today. R is the interest rate. Remember, we need to take interest rates and turn them into from percent into decimal, so divide by 100. And then N is the number of years that you leave the money alone. So for example, if we took $4,000 and invested it for 7 years at 3.9% annual interest compounded annually, how much interest is going to be earned? So basically what we're doing is we're sticking $4,000 into a bank account and we're not touching it, we're leaving it alone. And at the end of every year, for 7 years, you earn an interest payment. So after the first year, you earn an interest payment. So now for the second year, you're earning interest on $4,000 plus a little bit more, so on and so forth. So we'll use our annual compounding formula and plug in our knowns. We know that our principal amount is $4,000, our interest rate is 0.039, and our number of years is 7. Now before putting things in your calculator, you want to do any basic simplifications first, like 1 plus 0.039. That's pretty easy to do in your head, just add those two together. You want to do as little on your calculator as possible, because the more you try to put in your calculator in one sitting, the more room you leave for making little errors. If you don't put it in your calculator correctly, it's not going to calculate the correct answer. So when we do 4,000 times 1.039 to the 7th power, we get 5,228.40022. Now, future value is measuring money, so we're going to round to dollars and cents. So that means that the future value of this account is $5,228.40. But notice what the question asks. It wants to know the interest that was earned. So how much additional money did you earn on top of the principal $4,000? So $4,000 of this future value is what you started with. So the account has $5,228.40 after the 7 years, but it started with the $4,000. If you remember a formula we had talked about before, future value is your principal plus your interest. So we know what we ended with, we know what we started with, now we can find the interest that was earned. Subtract the $4,000, and we get that the interest we earned in 7 years is $1,228.40. Now this formula is good if you just get one interest payment every year at the end of the year. A lot of banks or other things like CDs and other ways of earning interest have periodic compounding, which means you get an interest payment more than one time a year. A lot of banks do 12 times a year. You get monthly interest payments. So the future value with periodic compounding is P times 1 plus R over M, all raised to the MT. P is still the principal amount, S is still the future value, R is still the interest rate, turned into a decimal. Now M is the number of compounds you get per year. This is the number of times you earn an interest payment each year. And T is the time, which again, usually measured in years to make sure that the interest rate and the time matches. So here are the keywords to look for when you're talking about periodic compounding. Annually means you get an interest payment once a year. Monthly, every month you get an interest payment. There's 12 months a year, so that would mean M equals 12. Weekly would be 52, daily would be 365, we ignore leap years. Quarterly would be 4. Quarterly means you get an interest payment every quarter or every 3 months. Semi-annually means every 6 months, twice a year. And then very rarely do you see hourly or each minute, but if you do, then these are the conversions you'll use. So for example, what is the future value if $3,500 is invested for 3.5 years at 7.25% interest compounded quarterly? Compounded quarterly means you're getting an interest payment 4 times a year or every 3 months. So the first thing you want to do is you want to find all the components to the formula. So we're looking for the future value. We know our principal is $3,500. We know the time that we're going to leave it there is 3.5 years, which is 3.5. We know our interest rate turned into a decimal is 0.0725. And then a number of compounds, if you're getting it compounded quarterly, that means you're getting 4 interest payments per year. So now we can plug it all in. S equals P times 1 plus R over M to the MT. Plug in our knowns. Now again, we want to do any simplifications we can in our calculator before trying to do one big calculation. So I'm going to take this 0.0725 divided by 4 and figure this out. I'm also going to do the 4 times 3.5. The less you put in your calculator at one time, the less room you have for error. Now this is another basic simplification we can do right here. And it's a lot easier to put 3,500 times 1.018125 to the 14th power in your calculator. And when you do, you get 4,500.735256. Now S is your future value. It's measured in dollars and cents, so we round to the nearest penny. So the future value of this account will be $4,500.74. Let's do another example. Now we're going to solve for a different variable. What interest rate do you need for a future value of $10,000 if we invest $7,500 into an account for 5 years, compounded weekly? So we're going to get an interest payment every week. We're found a bank that's going to give us an interest payment every week. We're going to leave this $7,500 in that bank account alone. We're going to leave it alone for 5 years. And at the end of the 5 years, we need $10,000. So what interest rate should we ask the bank to give us? So let's find all the components that we know. We know the future value, S, is 10,000. We know the principal amount, P, is 7,500. We know T, we're going to leave it in there for 5 years. And we also know the amount of compounds is 52 compounds per year. So let's plug all these known values in. And we get 10,000 equals 7,500 times 1 plus R over 52 raised to the 5 times 52 power. Now, do any basic simplifications. We can do that 5 times 52 to get 260. So now we need to solve for R. Okay, so we're going to work the furthest away from R and get R by itself, isolate the variable. So we'll start by dividing by 7,500, and we get 1.33333333. Don't round. Save your rounding for the very end. If you round too soon, then it might make a big difference at the end. So write out the long decimals, write down exactly what your calculator says, and keep those long decimals until the very end when we can round to whatever number of decimal places make sense. So now we have all these 3's equals 1 plus R over 52 to the 260th power. So the next thing we need to get rid of is this 260th power. What's going to undo raising to the 260th power would be taking the 260th root. So we're going to take the 260th root of both sides. So we get the 260th root of 1 point, all those 3's, is equal to 1. So now this 260 goes away, and we're just left with 1 plus R over 52. So how do we put that in our calculator? Remember, we don't have a button for the 260th root. We really only have a button for the square root on our calculator. So we're going to take this radical and we're going to turn it into a rational exponent. The 260th power is the same thing as raising to the 1 over 260. But when you put this in your calculator and you put that radical or that fraction exponent in, make sure you put it in parentheses. And when you do, you get 1.001107082 equals the 1 plus R over 52. Remember to save your rounding for the very end. So now to work getting R by itself, we'll subtract 1 from both sides. And now to get rid of the 52, we'll multiply both sides by 52. And we get R is equal to 0.0575682573. Now that we're at the end and we figured out what it is, decimal, for interest rates, we usually round to about 3 or 4 decimal places. If it's not otherwise specified, then go ahead and just make sure that your interest rate has 2 decimal places when you put it into a percent. So that means round to the 4th decimal place here. And we would see that our interest rate, we would need about 5.76%. Okay, we have one more type of compounding we're going to talk about, and this is future value with continuous compounding. Continuous compounding means you're earning interest every millisecond of every second of every minute of every hour of every day. You're earning infinitely many compounded interest payments. So we can't really plug in m equals infinity because you can't divide by infinity or multiply by infinity or raise to the infinity power. So we have a brand new formula, and some people refer to this as PERT. S equals P times e to the RT. That e, remember, that's that same natural base, which is approximately 2.71828. So S is still the future value, P is still the principal, R is still your interest rate turned into a decimal, and T is still the amount of time, usually in years. And then E is that magic button on your calculator, which again, that irrational number, about 2.71828. So if we took $17,000 and invested it at 4.2% compounded continuously, how much will we have at the end of 5 years and 4 months? So the first thing we need to do is we need to put our time into years. So 5 years and 4 months, well, that's going to be 5 years plus we need to turn that 4 months into a year, so that's 4 over 12, which gives us 5 1/3, or 5 plus 0.333333. Again, save your rounding for the end. So now our time is going to be 5 all those 3 years. So now we can find all the components that we can plug in. Our principal amount is $17,000. E raised to our interest rate is 0.042 times our time, 5.333333. When you put this in your calculator, keep this entire exponent in parentheses, and it turns out to be 21,268.20733. This is future value, so we round to dollars and cents. So the account will contain $21,268.21 if we leave it alone for 5 years and 4 months. So that's how we do periodic compounding. With periodic compounding, we don't add any money and we don't withdraw any money. We just take one lump sum and we leave it in the bank account completely untouched. All it's doing is earning interest. We'll talk next time about what happens if you make continual payments, things like that. Until then, see you then.